All right, guys, this is the second part of the 4.2 videos. And we're actually going to kind of dive deeper into experiments here and some of the things that we will do in order to create a more valid experiment. So we're going back to the caffeine experiment, right? And so last time we talked about how, for example, someone like myself who drinks a lot of coffee, obviously caffeine isn't going to have such a big impact. And so how do we control these things? What can we do to make sure we can control for confounding variables? So that's kind of what all this video is about. So first thing we can do is have random assignment. And so what is the purpose of random assignment? It is that experimental units are assigned to treatments using a chance process. And the reason why we do this is that it helps control bias. Okay, you create groups that are similar to one another. Okay, and again, that doesn't mean they're more accurate, right? It just means that you're going to have something that's more encompassing of your population, and therefore you have more valid results, right? So going back to the example of the high school, right? If I take a small sample, if I don't have random assignment, right, there's a good chance that I'm going to get all students that get A's and B's on a regular basis. Take a larger sample, have more random assignment, and all of a sudden I'm going to get the kids that don't try as hard. And so then whatever you're trying to study actually has or you can say it actually has an impact. Okay, moving along. How do we randomize? What is a completely randomized design? In a completely randomized design, the experimental units are assigned to treatments completely by chance. Because everyone's got an equal opportunity of being selected to one of the treatments. What is replication? We talked about this last week as well. This is one of the big things. Replication is when you impose each treatment on enough experimental units so that the effects of the treatments can be distinguished from chance differences between the groups. Okay, so that's kind of the point of experiments. It's also called significance. And then you also ensure that there are an adequate number of units in each treatment group so that the two groups are as equivalent as possible. A replication can also refer to repeating the process with different subjects. This can help us feel more confident applying the results to a larger population. If your results are consistent across different groups, then you're more confident in saying that it's going to apply to kind of like everybody. What does it mean to control other variables? Is another important thing. This means to hold all other variables. Holding other variables constant for each member of both treatment groups, okay? Good example of this would be time, right? So let's say you're looking at like a new diet or something. You want, the control group and the experimental group to have the same amount of time that they're on this, new diet, for example. Okay. So what are the two major benefits of controlling for other variables? You control for confounding variables and reduce variability in the response. Okay. So I'm not going to type all this out. We can kind of talk about it a little bit. But here, if one treatment group was given Coke, which has sugar in it, and the other one was given caffeine-free Diet Coke, then sugar and caffeine would be confounded. To prevent sugar from becoming confounded with caffeine, we need to make sure that both treatment groups get the same amount of sugar. Okay. So sugar is also obviously going to increase your heart rate, and so that's why that could be a confounding variable. Okay, and then the next one, reducing variability. So let's say you let these people who are drinking the soda drink as much as they want, or as little as they want to. Then obviously the amount that they drink is going to have an impact on their study. Right? So that's going to lead to more variability, and so that's obviously going to lead to less confidence in your results. Okay. Make sure you read this paragraph. Okay, this is really important. Okay, so now let's say we did the caffeine experiments and you got some results. What could you do, right? So here you're going to compare the means of the two groups and find the difference, okay? And now the question is, are these differences large enough for you to be convinced that the caffeine caused a change? Okay, that's the ultimate question. So that's going to lead into what we talk about kind of the next couple of chapters after this, which is significance testing. And so it's like, okay, well, now that we notice a change, is it large enough that we're going to be like, they're actually going to say it's significant? What are the two explanations for evidence? So the first one, there is no difference in the effectiveness of the two drinks. We got a difference due to the imbalances of the random assignment. And so basically what that means is that obviously when you have random assignment, both groups are not going to be exactly the same. So if your differences are so small that it could have just happened because one group is slightly different than the other, then obviously there's no difference. Then we're not going to say that this is convincing. On the flip side, there is a difference in the effectiveness. And so what that really is saying is that, okay, well, yes, we have these these small differences between our groups, but the difference that we saw in the caffeine is so large that it's it's stronger than the difference between the groups. So that's kind of a really important point as we get towards significance testing. Okay, so now we compare. How can we determine if evidence is convincing? Compare, observe is kind of what I just talked about. Difference in means with what could happen by chance alone. And so now what does it mean for results of an experiment to be significant? The results are significant if they are unlikely to occur because of possible imbalances created by random assignment. Statistically significant results implies convincing evidence. Okay, and this is going to be p-values. That's what's coming up. Okay, I'm going to talk about blocking in the next video, and then we're actually going to do some practice with comparing answers here at the end. That's going to be it for this video, guys. We'll do one more video, and that'll be the end of this unit. So if you have any questions, please let me know. And if not, have a great rest of your day.